Let's explore C Makefiles and how they automate the compilation process for C projects. Makefiles define rules for building C programs. This automation is especially useful for multi-file projects. Makefiles enable incremental builds, meaning only modified files are recompiled, saving time. They also help manage the dependencies between your source files. A makefile consists of targets, dependencies, and commands. Targets define what to build, dependencies list the files needed to build the target, and commands specify how to build the target. Variables can also be defined for reusability. Each rule instructs the make utility on how to create a target file from its dependencies. Here is an example. At the top, the CC variable is set to GCC, indicating the compiler to use. The C flags variable is set to wallware, enabling all warnings and treating errors as fatal. The program target depends on main.o and helper.o. The command to build program uses the GCC compiler with the specified flags, linking the object files. The main.o target depends on main.c and header.h. The command compiles mainly into main.o. Similarly, helper.o depends on helper.c and header.h, with a command to compile helper.c. In a makefile, a rule specifies how to build a target from its dependencies. The basic structure of a rule is as follows: target, dependency 1, dependency 2, and so on. After that, there are commands. Make executes the commands when the dependencies are newer than the target. Here are some examples. In the simple rule example, main.o depends on main.c and header.h. The command rebuilds main.o when main.c or header changes. In the multiple targets example, all depends on program 1 and program 2. Program 1 depends on program 1.o, and the command go program 1 program links it. Similarly, program 2 depends on program 2.o, and the command go program 2 program to links it. Using variables in makefiles makes them more maintainable, easier to modify, and more readable. Common variables include CC for the compiler command, C flags for compiler flags, LD flags for linker flags, and OBJS for the list of object files. This is an example of how to use them. Here, C is defined as GCC, C flags as wallware02, LD flags as LM, target as myprogram, and OBJS as main.utils.oparser.o. The myprogram target depends on the object files. The command to build it uses the CC, C flags, and LD flags variables. The pattern rule %o% C files into object files. The clean target removes the object files and the final executable. Pattern rules use the % symbol as a wildcard to match any file name. They allow you to write a single rule that applies to multiple files, making your makefile more concise and maintainable. Instead of writing individual rules for each object file, use a pattern rule. This pattern rule example demonstrates how to use pattern rules in automatic variables. Instead of writing individual rules for main.o and duals.o, a pattern rule %o%fsh is used. This rule compiles any C file into its corresponding object file. Some automatic variables are @ which represents the name of the target, <sign which represents the first dependency, * which represents all dependencies, and * which represents stem. For a practical application, D is set to GCC, C flags to wallware, OBJS to main.utils.oparser.o, and target to myprogram. The myprogram target depends on the object files. The pattern rule compiles C files into object files. The clean command removes the object files and the target. Phony targets are targets that don't represent actual files. They're used for actions like cleaning up or running tests. Declare them with .phony to prevent conflicts with actual files of the same name. Common phony targets include all, which builds everything, clean, which removes build files, install, which installs the program, and test, which runs tests. In this example, .phony declares all, clean install, and test as Phony targets. The all target depends on myprogram. The myprogram target depends on main.o and utils.o. The clean target removes the object files and the executable. The test target runs the executable with the test flag. The install target copies the executable to the user local bin directory. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.